thanks everyone for showing up. I was talking to Hugo about this. I don't do more of this here in Malmö. We certainly want to do more of this in terms of organizing meetups. We have a ton of space. We have a ton of money that we need to spend on pizza and stuff like that. You should be able to add all of these together. We want to recruit engineers. You add all that together, there should be more meetups in here. So thanks everyone for showing up. So my name is Emil Ephraim, and I'm one of 3 founders of the company. How many people in here know anything about Neo4j, the product? Okay, so most people. How many know anything about Neo4j, the company? All right, so I'll tell you, for the people who didn't raise your hand, I'll tell you a little bit about the company. I'll tell you a tiny bit about the product, and people who knew a little bit about the company, I'll add a little bit more of color. So for those of you who didn't raise your hand, either of the two, the really quick summary of what it is that we do is that at the highest level, we're a database company, but we have a little bit of an unusual view on data. We used to be part of what was called the NoSQL space or the non-relational space. We're not a relational. We take a relationship-centric, a connection-centric view of data. And basically, the premise behind the company is very, very simple, in fact, almost simplistic, which is that the world is becoming increasingly connected. I'm carrying 2 phones in here. My car has 5 computers connected to itself, IoT, social media, whatever. We all know that the world is becoming much more connected. Data models the real world. So as the real world is becoming more connected, so does data, which is great. The challenge is that if you put a lot of connected data in an existing relational database or tabular database, that puts a lot of tension. It's doable, but it's very awkward. It's slow for developers. It's slow in terms of performance. It's not great. And so what we've built is a database that is centered around relationships in data. So that's kind of at the highest level what it is that we do. We got started actually here. This is 2010 at MINC, the Malmö incubator, 150 meters away from here. Which this is part of the early team. This is maybe half of the team in 2010. We actually were never formally part of the incubator part of it, but we were sitting in that building. In 2010, we opened up our first office in the U.S. in California, and in 2011 we moved the headquarters to California, and I moved there. But we started building the commercial organization over there. But Malmö was always the center for our engineering, so we called it our engineering HQ. 2 years ago, I moved back, so I'm now based here. We've chosen what's called a category creation strategy to the market, which is that if you invent a new thing, you invent this thing, for example, right? You can call it a product. This one is called, I don't know what this one is called, Clicker ABC XYZ or something like that, right? You can just call it a product name, but it's helpful if it also has a category name. So this is, I guess, a clicker or something like that, a presenter, right? Or Levi Strauss, when they invented the first pair of jeans, they didn't say, hey, these are pants. They are pants, but they're a new type of pants, right? We're a database, but we're a new type of database, and that's called graph database. And we were the team that put those 2 words together for the first time. Graph existed in mathematics gazillion years ago, right? Database, of course, existed. We put the word graph and database together. So when we did that, we were in the category of 1. There was just us. Neo4j is a graph database. There were no competitors by definition because we just invented the term, right? Fast forward to today, and this is a hugely valuable category with a ton of competitors, a ton of other vendors who provide graph databases. In terms of commercial adoption, it's quite stark. 76% of the Fortune 100 are using Neo4j in some shape and form. Some examples from various industries. 20 of the top 25 global banks, 20 of the top 20, also known as all, of the banks in North America. And you can see some of the other examples in here. If you've ever booked a flight ticket, you've used Neo4j. 99% of the flight tickets in the world are calculated using Neo4j, figuring out if I'm going to go from Malmo to Seattle. Should I fly directly? No, you can't do that. So then you need to hop through San Francisco, and then from San Francisco to Seattle. That's one path through the graph, right? Or you can go to Chicago and then Chicago to Seattle, right? That kind of stuff. If you've ever used an ATM, which is something that's not an example that goes over well in Sweden because there's no cash in Sweden anymore. But in the US, they use a lot of cash. And so 20 of the top 20 are using so I just mentioned that. So basically, in order to take money out of an ATM, like you've used Neo4j in the US. So a couple of examples of that. So that category that I talked about before, graph databases, is now identified as one of the 10 hottest categories in data and analytics. This is some comments from Gartner, a big analyst firm. This was published by a partner of ours, which is the Graph Technology Landscape, which is pretty crazy. This term that we invented here in Malmo less than 10 years ago is now filled up by all these vendors. Some of these things are stretched, like they include things like AWS and things like that, which are obviously not graph-only companies, but most of these are graph-only companies, right? None of this existed. Even the category, the concepts didn't exist 10 years ago. Pretty amazing. There's a site called DB Engines that measures popularity of databases. Popularity of types of databases. And so they measure things like tweets and LinkedIn job offers and things like that, PageRank Google searches, right? And here's the growth of a bunch of these categories. And here's the growth of graph databases since 2013. So it's the fastest growing category in all of data. And this tiny little piece of software that was invented in Malmo, right, is now by far the dominating one inside of this category. Like our score here is 50, whatever that score means. It's a computation of all these things that I mentioned before. You add up all the other ones in here, right? It's less than 50. It's pretty cool stuff. Just to give you one sense, like one flavor of what it is that people do with our technology. How many people in here remember the Panama Papers, right? Alistair is raising it. Yes, good. So probably so this is like the biggest news story of 2016 until Brexit happened, and then Trump happened. 2016. Woohoo! Great year. Yeah, tons of good stuff. But so basically, to refresh you, that it was a law firm had a leak. That law firm was specialized in offshore tax haven planning, which can be used for legal tax planning purposes, or it could be used for tax evasion, right? Which obviously is illegal. They're based in Panama, hence the term the Panama Papers. And it got leaked by a couple of German journalists that got a data dump, 2.6 terabytes of data, that they said this is all the internal emails, all the like forms, all the documents for this particular law firm. Do you want to look into this? They said yes, but how the hell do I go from 2.6 terabytes into some kind of news story? So they ended up contacting this international organization, which sounds very fancy. It's 15 people that are focused on data science and data journalism. And they together managed to pull this out into 11.5 million documents. And these are like it's an email scan documents, like whatever, government forms, bank statements, things like that. And what it is that they were looking for is things like this. If you even step aside from technology and data, it's stuff like this, right? A pattern in data, like a person who has an account with a bank, right? Which is obviously true for Hugo and for me and for Jens and for like everyone in this room. This is not a very interesting pattern. It's a pattern. But if you start building on this pattern, it becomes a little bit more interesting. So let's say that this person lives at a street, at an address. Another person lives at that address. That person is an officer of a company which has a bank account registered in a well-known tax haven. All of a sudden, this pattern starts becoming much more interesting, right? So you can look at this from this example. You can abstract it a little bit. You can see that these are types of concepts, right? And in the graph world, we call these nodes. The circles we call nodes, and the arrows between them, the connections, we call them relationships. If you attached key value pairs to them, think JSON, right? Then all of a sudden you can model everything, right? So these are the fundamental building blocks of a graph database like Neo4j. It's really cool if you can express data in this form when you have these whatever 7 nodes. There's of course even better if you can do it when you have 1 million nodes or 1 billion or 11.5 million nodes, right? Or 1 billion nodes. You can truly do this at scale. That's when you start being able to uncover some really interesting things. This was not a hypothetical example. This is actually the example of Sigmundur Gunnlaugsson, who is now the former Prime Minister of Iceland, who actually ended up to resign because of the findings in the Panama Papers that they found by using Neo4j, right? Because this is exactly the same graph as in the previous example. His wife was registered to this, was officered in this company that was registered to the Bahamas, right? And he had not disclosed that to the Icelandic public, and because of that, he ended up having to resign. Huge story, tons of news about this. Ended up winning the Pulitzer Prize the year after. It was a pretty big story worldwide and huge for us too. So one example of the type of impact that we're having. I humbly call this impact an example of saving democracy. Woo! So that's one example of the kind of stuff that we're doing. Couple more examples of the type of impact that we're having. This is, by the way, before I go into that, one of the more interesting aspects of doing horizontal technology. Like if you're doing very vertical technology, you know all the use cases and you know sometimes all the people that are what they're using it for, right? With horizontal stuff, like you work on very fundamental things like the nature of data, and we're good at doing connected data and patterns and things like that, right? And then all of a sudden the use cases are very, very surprising and sometimes very delightful, right? Another example of that is NASA, who's now on the record saying that thanks to Neo4j, humankind will get to Mars 2 years earlier. They used us in Project Orion to find a construction problem, or the solution to a construction problem with Project Orion, which is an amazing story that I can tell you all about at some point later. And in the third example, I personally know of at least 20 projects right now using Neo4j to find the cure for cancer, which is probably, if I look at everything that we're doing, I love all our customers that'll pay us a bunch of money so we can buy pizza for you guys. I love that, but this is probably the most inspiring thing to me, right? The tiny little piece that we're doing in helping to find the cure for cancer. So that's, at the high level, a few data points about Neo4j. I could talk for hours and hours about this, but I'm not going to bore you about that before you get into JavaScript syntax or something, something like that. Final thing, we are hiring. We are about 300 people right now in the company. We want to be closer to 500 by this time next year. If there were 100 qualified engineers outside this door today, I would hire all of them right now. This is the key constraint in the business right now, is finding qualified engineers. This is, look, I'm at the center of it. I'm drinking my own Kool-Aid. I think objectively this is just about the best engineering team in all of Europe, right? So that's, I think, a good selling point if you want to work with fantastic colleagues. Having a great impact. So if you're interested in this, there are 2 people for you to talk to. There's a bunch of Neo4j folks here, like Hugo, and I like if all of the Neo4j people can stand up, that'd be great. And okay, you're already standing up. So the first person is Jennifer over there, right? So remember Jennifer. Please talk to her. The second person is Alistair over there. I finally found a good use for that picture. Okay, that's a complete joke. I used that picture in all my presentations, right? So talk to any one of the Neo4j folks, but Jennifer and Alistair are good people to remember, or drop line to jobs at Neo4j. Awesome. Thanks for paying attention, and have a fantastic meetup.
Hello, everyone. I'm Hugo. I joined Neo about 6 months ago, I'd say, in the beginning of June. Spent 5-6 years, something like that, working with JavaScript. And I would basically just like to talk about a piece of technology that I discovered working here at Neo. One of our products we have is called Neo4j Desktop. It's usually seen as the entry point for new developers who want to just kind of explore Neo4j, build some kind of web app, something, and just get started. So I suggest you check that out. You just go to neo4j/download, and you can download that app. That app is built on Electron and provides a host of different services. Amongst others, it allows you to run what we call graph apps, which are basically just React applications, static HTML bundles. And as I'm sure a lot of us can relate to, that can be a real issue in production, especially if we don't have the best quality apps we're running. If one does something weird or something like that, but we still obviously want to offer our users the best possible experience using desktop. We don't want desktop to fail. We want desktop to keep working and just give a really smooth experience. So to that end, I want to tell you a little bit about something called Electron Browser View, which basically allows us to do fully multi-threaded views in JavaScript. Completely multi-threaded. I'm not going to do too much code. I'm going to do a shameless plug because I love my own stuff. I'm going to do some background and history. Just quickly look at what is Browser View. Actually, Jennifer, could you just hit the light switch in the corner there? No, behind Oscar. Behind Oscar. The other one. There. Sorry. I'm going to do what is Browser View? How do you use it? Look at a demo, and really in the demo, what I want to show you is I'm going to mount two applications. I'm going to give one of them something really heavy to do, basically make it crash or freeze, and we're still going to have everything else just running super nice and smooth and be able to continue with our daily business. I want to tell you a bit about an industry case. Slack went through this journey, and they have some super interesting outcomes from that. They've done some really good articles. And then finally, some final thoughts that I have working with this technology, reading about it, and what just interesting things to maybe discuss for the future. So the background, like I just said, we want to enable plugin architectures. That's something that we see happening more and more and more. And really what we're saying there is we need to embed web apps in Windows, right? We want separate teams to own their parts of an application, and we don't want these teams to have to continuously communicate and sync up with each other. We want to be able to just give people, kind of like the Spotify model, you're in charge of the play button, you're in charge of the sidebar, you're in charge of the album artwork preview, and they don't really have to continuously discuss and be in meetings. They can just build their stuff, and it just goes together without any major issues. And we want all of that with stability and performance in what used to be a single thread. So that's the background of Browser View, and before that, web views, and before that, iframes, but really where the web has been moving lately as we enter the more native areas. Browser View as such was created by a company called Figma, an interactive design tool, in 2017 to overcome issues with web views. Web views originally came from, I believe, Android and got introduced into Electron through Chromium. So it's coming directly from Chromium into Electron. It's basically just a tag, just like an iframe, but with separate processes. It has a host of fundamental issues, drag and drop, performance, focusing, and all of that is coming from inside Chromium, meaning that fixing bugs was really slow. It was really hard to get changes through because changes to Chromium core is, well, something that people want to do as little as possible. So Figma basically needed a way to continue on the path they were doing, completely separate views, but they needed to be able to address issues and, above all, maintain performance. Figma's big thing is to be as performant as possible. So they made Browser View. What is Browser View? It lives in the operating system window hierarchy, not in the DOM. So that's one very big difference between iframes and web views compared to browser views, and I'm trying to show that with my awesome painting skills. You have the iframe web view style thing, where you have the browser window in Electron, the IPC renderer process, the front-end process. You have the main application, the index file it has mounted, and then you add web views, which is just an inline tag. It goes in, it has its own process, but it's still part of the DOM hierarchy, and there's all kinds of weird stuff going on where they meet. When it comes to a browser view, what I'm trying to show here is they both live in the same browser window, this top level rendering process, but then they actually sit next to each other. So the browser window and the browser view are in no way nested. They don't really know about each other at all, apart from this loose coupling that, hey, you're in the same frame. And should one of them go bananas, that doesn't really have an effect on the other one. They're not in their own, or they're not in each other's path. They have completely separate threads, unlike iframes. Iframes still share at least a UI thread. I don't know what they do with the worker threads, but they share that. So you never really have to worry about things freezing up or blocking something. And only the really big issue you get is, since we've left the DOM hierarchy, you no longer have this kind of natural flow of content. Elements in the browser window app have no idea about the other one, and they can't position themselves to each other. So that's really the only major trade-off. How do you use it? This is very white. I changed my color very recently and didn't have time. Yeah, I know. So on the right here is like super boilerplatey Electron code stuff. You create a browser window, and there's all kinds of stuff goes into there. And then you can attach a browser view. So what we do is we just create a view. And what I really want to highlight here is the preload script. And what's really special about the preload script lives in a really strange state of being both in window and in Node.js. You have full access to window, and you have full access to Node.js in that script. So what I've done there, for example, is I've set up various APIs for sending events back and forth through the IPC. So being able to get my view to talk to my backend and do you can just mix Node and window stuff together there, assign them to a global parameter, and have it fully available to you later. There's all kinds of other stuff. Please see the documentation. You load a file or a URL, just any kind of static web resource. You set some view bounds at the bottom, and then you just have to kind of think about it like you do with position children. So let's look at a little demo that I've put together. So this is a sample app I've made for a library called Viewtron that I'm going to shamelessly plug here in the next slide. And all it really does is let you work with browser views. So I just have some layout stuff here. You can add rows, columns, views. You can set dimensions. So we can add a row. We can add a column to that row. We can add oops, I screwed that one up. There you go. We can add more stuff. We can, for example, set the height of this thing. Really what I'm trying to show here, if we take it out of full screen for a second, is even though this is completely, absolutely positioned, this is pretty responsive. The delay you're seeing is actually my throttle. If you look at the actual views and how they're scaling, if you look at the responsiveness of these websites inside of there, that's moving really, really smooth. And if I just took my throttle off, you could get some really, really good resizing without people really even knowing. But if we were to look at the source code, so this is the app area, so to speak. The only thing that's in here is some stuff, a third-party library needed to be able to do positioning. There's absolutely nothing in here about these views. They do not exist. As a matter of fact, if you were to put a listener on the mouse and pull them over, you wouldn't see your mouse anymore. You're in completely different views. Why is this important? Well, apart from me not being able to God. Oh, there you go. So we can do some cool things in here. For example, here we have careers at Neo4j, and we definitely don't want to break that website. So we have that one running, and what I'm going to do is I'm just going to take a little code snippet I made here, paste it in, and then we're going to take the other one and paste it in here. And basically what we have now is a little view that is showing the time. And then when I click this thing here, we're going to enter a beautiful little infinite while loop. What I'm trying to highlight here is somebody on the right is doing something bad, something stupid, something is that we shouldn't really see. And in all other contexts, that would have some kind of effect on us. So you can see here, CodeMirror is completely losing responsiveness. I can't really interact with this thing anymore. It's just not happy. But over here, it's like it never happened. There's absolutely nothing impacting these views whatsoever. We have fully, it looks a bit choppy on the meetup, but we have completely smooth, nice rendering because they're just in completely separate processes, and we don't have to care. We can get rid of that column, and we're all good. Another thing that's super interesting is, so let me put this thing somewhere around here. What I'm trying to basically say is, I'm going to put it in some kind of state, and we hide this view. Fair enough. This could be, for example, you're switching tabs in Slack. If we just put it back, what's really wonderful about these guys is that the view is still alive underneath. You have a fully functioning JavaScript process running underneath. You can continue sending events to it. You can continue communicating to it. No problem whatsoever. So you can hide these views. You can do all kinds of cool layouts with them and give people a really first-class native experience without any loading screens or anything like that. So that's kind of it. There's this is a fun little demo for people who just want to play with layouts. It's built on something called Viewtron, which is made by yours truly. Really, all this one does is, for those of you who don't want to work with the low-level API, it just gives you that. Add rows, columns, remove views, everything. And what I thought was really interesting, this is a little bit of a sidetrack, but I wanted to tie back to David Valier's speak last time, I believe it was, on consequential Redux actions. He had a really, really good speech about a different way of doing Redux. And I just wanted to show how that played into Viewtron. So this is, for those of you who were here last time, a very familiar site, but basically the notion is actions that have reducers and consequences all in the same file. And I thought this example was pretty good. Somebody wants to remove the row, so we remove the row. But as a consequence, we now have to get rid of all the columns that row had. When we go there, same thing again. Remove the columns. And then, of course, if the column had views, we have to remove the views. And as you can see, that's the end of the line for this particular chain of consequences. So I thought that was a really good pattern, and that speech really, really helped with what I thought producing cleaner code. Cool. Yeah. So to look at a more specific case, an industry case, we have Slack. Slack was making extensive use of web views for the reasons mentioned before. They really want to separate things. They want to have separate teams working on their stuff and not really have to worry about stepping on each other's toes. They were facing bugs that just languished because, well, it was part of Chromium. So they had issues with rendering. They had issues with random reloads, inactionable error screens, and they were just spending a lot of time fixing things as opposed to making things. They have their entire architecture is built around having completely isolated child applications and views, and then being stitched together through a main process. What is super interesting, and I'll share links to the actual articles that are really, really good. They've essentially created a clustered Redux. Think about that for a second, because I had to. They've created a clustered Redux that achieves eventual consistency. It's the work of a madman, but it makes sense. What they do is they bounce actions between views using the Electron IPC channel. Just to mention the core of the stack, they're building with TypeScript, using Electron Redux and Redux Observable to achieve this effect. In their own words, if an action is dispatched in a renderer process, the renderer completely ignores it and just sends it to the main process. If an action is dispatched in the main process, it's handled there and then sent back. And then the renderers, in this case, all the separate child views can just kind of reapply whatever this action was. This allows them to have the main process as the one true store, which is a real issue when you have multiple views that are supposed to give users the feeling of one. Super interesting article. I'll share the links. Definitely check it out. I've never seen anyone do Redux like that before. There's one big caveat with this. You get a lot of processes. Every view and every window spawn a render process, and every render process comes with an overhead. So you need, if you go down this path, which I strongly recommend, you should be very considerate about memory and the number of processes you're running. Basically, you need to have an architecture that can consider how to unload views and centralizing shared processes. So good example is you switch chats in Slack. The other chat, it will still have notifications, maybe something else going on, but how can you remove as much of that process as possible to make sure you don't end up, consuming 500% of CPU or something like this. So my final thoughts, it's still early days, but there's some really big opportunities. My first thought, I was kind of playing with, you have desktop first versus mobile first development. My first thought here is this then maybe the start of something called native first development, where I don't even care about the browser anymore? I don't even build stuff for the browser. I just tell people to install apps because I can now do so much more in this native environment. I'm finally free of blocking shackles. I don't have to continuously look over my shoulder or keep track of what other teams are doing or be afraid of third-party plugins coming in and ruining my app. I can just forget about that and focus on the stuff I do, and then give users a sane way to bail out if something stops working. Finally, this is completely outside of browser view as such, but because of the crazy clustered Redux thingamabob they made, and this is a little bit also coming from the GraphQL stuff that we've seen happening. One thought I had after all of this, like having a main process with a bunch of child processes rendered on top, is it possible to look at UI state as nothing more than a read replica? I don't know, but I would love to hear people's thoughts. And that's me. Any questions? Yeah. 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 So what is IPC? IPC just stands for inter-process communication. It's basically just a post message. You would see the same thing in the new multi-threaded node systems. It's just a way for sending serializable data between processes, or more specifically from renderer to main, and then
Yeah, I can certainly see how this increases stability, and also performance. And I was curious during the time that you worked with it, if you discovered that there is also like a penalty to starting to use it. Like, is there some pitfalls? Does it decrease performance or decrease stability in some aspects if you do the wrong thing? Or
so pitfalls. The biggest one I've discovered so far is it's quite easy to break. So if you accidentally start doing too much with the bounds, or if you overload, if you're too aggressive on your management, the reason I have that throttle in, for example, is it feels like this technology can still sometimes kind of freak out, and the underlying, I think it's OpenGL renderer, just craps out, and you get really weird layouts that explode all over the place. So it's no, it works really well as long as you're gentle with it. You don't want to, for example, when you do a resize or something like this, you don't want to just absolutely pump every single resize event through. You can, but it seems to have some kind of issue there. I feel like that's more the maturity of the implementation, though, than it is the actual technology they're using. Another thing, well, it's really hard to drag and drop stuff. Like, it works really well when you use just the built-in OS X stuff. You click a piece of text and you drag it in between. That works super sweet because we're just in the OS hierarchy. But if you have a little folder you've drawn in one app and you want to drag that folder to the other app, that's hard. They don't know. They're completely separate in two separate worlds. So that's the two biggest ones I've found so far. Yep.
Could this be something that causes the community writing JavaScript on desktop to diverge too far from the web community? Because the web community's solution to basically not blocking the UI thread in the same way currently is to use what Facebook and Google has worked on with the scheduler, and that you use cooperative multitasking, which is like a concept pretty common, at least in operating systems. Could this cause like them to diverge so much that libraries and such would be like one even further than there is now with Node and the web browser? The libraries like not being able to work between the platforms.
That's a super interesting question. So you're asking basically, could this kind of make people not focus so much on all the great work that's going into improving the web's ability to co-host or share processes?
Yeah. It sounds like there's one solution at the desktop level that goes in another way than what Google and Facebook try to push the browser.
I don't know. I don't know. I think it's a great question. I think it's something we should all kind of talk about, because I really don't know. The way I see this is based on my experience being in these projects where you have really big applications with lots of teams contributing small pieces, and you just need a way to keep it all somewhat sane. So I would say it definitely has a place in those environments where we just can't be that disciplined. But yeah, I understand what you mean. Maybe it does also make it a bit too easy not to be disciplined. So great question, but I don't really know. Yeah.
So much is the overhead ratio?
That's a good question. Yes, it is, and which is why I actually included reducing Slack's memory footprint in there, and they've done some really interesting stuff in I don't know. We can just look at what we've got running here. Hopefully nothing embarrassing. Well, we've got WebStorm with 7 gigs, so there we go. Where is Electron? There you go. That would be one of these. That's one of these guys here. So I'm guessing this is the main view. I don't actually know. I haven't read up on that. I haven't noticed anything dramatic idling. And I haven't gotten that far in my work yet. So I don't know. But I feel like it's pretty good on modern machines anyhow. Yeah. So can I share anything between them? Well, whatever you can share between Chrome tabs is the short answer. They're essentially Chrome tabs without the Chrome. Yeah. Yes.
How do you deal with like something in one part of the thing that should affect something else but doesn't know?
Mm. Mm.
Do something else on some other.
Mm.
Make sure that you don't have semaphores or.
So question is basically how can Slack handle potential race conditions if something crashes and respawns or something like that? Short answer is I don't know what Slack is doing. What I ended up doing was leaning pretty heavily on GraphQL. So in parallel to having an event system, I actually lean very heavily on just treating the main process as a classic backend. So whenever one of my apps start, they just send, hey, give me this stuff, give me current state, and just not even take the fight. I don't know exactly what Slack's, and I haven't found any articles on that yet. Yes?
Yes, so we are on a single thread right now.
Mm-hmm.
But also have like browser and some parts.
Mm-hmm.
We're heading the Slack for the Spotify way. How would that work? The browser, like you have there's a no-go. Or how do you?
How do you mean users in both?
Yeah, so we do have using a regular Chrome.
Yeah.
But also download data.
Okay.
So like
Okay.
like Slack, they have the web app.
Yeah. Yeah. We have similar things at Neo. So the question is basically, can I have a web app that can function both inside and outside browser view? Yes, you absolutely can. The answer is as simple as it is ugly. You have to use the preload script to add something to the global environment to tell you that you're in the browser view. So what I do, for example, is I feature detect. I have this fixed name for this little API that I add to the browser view. So I check if window.foo, you're inside the browser view, and then your application just has to decide what it wants to do with that. Cool. I think that might be it, unless there's any more questions.
All right. Hello, everyone. Thanks for coming. Thanks for Neo4j for hosting this, giving me an opportunity to talk about some nerdy stuff. My name is Ali, and I don't know how to start a presentation. So I'm just going to say that I like weird, obscure stuff, and I'm going to talk about some of those. So how many of you guys have worked with JavaScript? Should be like all being shy. And how many of you have heard about that part of JavaScript? And how many of those people have found those part of JavaScript interesting? Oh, that's awesome. So then this talk is for you. And for the rest of the people. So what I have here is that I want to take a look at JavaScript from a different angle, from an angle where not many people usually talk about, focusing on the compiler. How do we actually interpret and execute JavaScript in a fast pace? So when we look at JavaScript, we typically look at it as it's a language where we have ECMAScript that actually shows, OK, these are the syntax that should be available for JavaScript. And then there is a TC39 committee who goes through those proposals and try to approve or disapprove some of the syntax that get added to JavaScript. So you can see that we have, like, I don't know, we have proxy, we have optional chaining, all those good things like classes that they have added in ES6. And then what happens is that there are compilers that have to deal with the rest of the stuff. So there is V8, there is SpiderMonkey, and there is, I think, JavaScript core, I believe, for Safari. And they have to like take the heavy lifting. They have to make sure that the new syntax that are coming available to JavaScript are as performant as they can. And that's the part that is usually not very visible to people, to developers who are developing in JavaScript. And that I found particularly interesting. And I'm going to show you some of the cases that how the compiler finds optimization that it can do to run the code faster. So my journey starts when I read this article, and I found it quite interesting. The title of this article was like, "What's faster, C++ or JavaScript?" And to me, it was like, how is that even a question? Of course, it's going to be C++. It's like a native language. It compiles into assembly, and it runs fast. And then I realized after reading this article, I totally recommend this. Pretty awesome. It's written by Francisca, if I pronounce her name correctly. She's one of the core team of V8. And she argues that there are a couple of things. There are numerous things that V8 engine people are doing to make sure that JavaScript can run as fast as close as possible to C++, and that I found pretty intriguing. And there is a case study that she did, and one of those was to be able to calculate prime numbers in JavaScript and C++ with the same kind of algorithm for both languages. And this chart, as you can see, is the chart of performance of JavaScript compared to C++ if we don't do any optimization for JavaScript. So if we go line by line in JavaScript and execute it as if it was an interpreted language, we get a chart like this. JavaScript is not doing very well. It's doing very, very poorly. But there are a number of things that you can do to improve that. And this is a chart that shows what happens after we optimize JavaScript. It's doing pretty darn well. It's not lower than half of what C++ is doing. And this is calculating, I think, 1 million or 100,000. I think, yeah, 1 million prime numbers under 10 seconds for C++ and almost like 16 seconds for JavaScript, which is pretty darn fast. And funny thing is about this article also that I recommend you to read is that at some point JavaScript is even faster than C++. That part I don't understand, but it's quite interesting. And this is how I imagine C++ developer after reading that article. There's a great talk by her. I totally recommend you guys to see. So there is often a price to pay. So one of the good things about JavaScript is like it's a dynamic language. It doesn't require, most people don't see that there is a compilation phase that goes to JavaScript. So this is something that you can see in your dev tool quite easily, that when you send a JavaScript to a piece of JavaScript to the browser has to actually compile and parse the file to be able to find the fastest route to run and execute JavaScript. And there are numerous things that they do in order to make it faster. They try to lazy load stuff. They don't need to parse everything. They just parse the part of the functions that we require to run. And they optimize the heck out of it to be able to run it very, very fast. Again, there are two amazing talks about like parsing that I will not get into. They are totally inspiring. If any of you guys are interested in those kind of dark alley, I totally recommend that. But what I want to talk about is the execution part, the interpreting JavaScript line by line and how we do it, at least how V8 does it. So I look at this code. This code is pretty innocent, pretty simple, straightforward. We have some prime numbers defined in an array. First of all, how is that array defined in the memory? I want to see that. And then we are just passing those primes to calculate the next prime, and then we push that number to the primes array. And yeah, this looks pretty neat, right? Pun intended. There's a neat or there also. But I want to see what's going on behind. These pictures are not copyrighted, by the way. I hope the owners are happy that I'm using them. So just to put yourself in the compiler's shoes, this is the code that compiler sees. They don't have any context or clue. They just see a bunch of variable names, and then they have to call that variable name. Apparently, C is a function that I have to call. And then I need to find the property D, which is push for the array, but the compiler doesn't know it. So it has to find that function push in the variable a and then call it, pass some parameters to it and see what happens. So what happens with V8 when you pass in the JavaScript file to browser, or Node.js for that matter, is that it goes through a certain number of phases. So it gets the source code, it parses it, tokenizes it, creates an abstract syntax tree that I'll show you, and then it creates a machine code. Well, it creates the interpreted language, and then that in turn will become a machine code that can run on the CPU very, very fast. So I have an example, the example that I showed you before. This is part of what it looks like as an abstract syntax tree. It looks like you could say a JSON blob. And then it gets converted to something like this that has some intermediate language. So this is like very close to assembly, not exactly assembly, but it's very close. So for one of all of these instructions, we are running like, I don't know, thousands or hundreds of lines of assembly code to execute the program. And then all of this in turn becomes assembly code. And this is very, very interesting to me because as I remember, I don't know how many people here know about assembly. Oh, perfect, awesome. So I cannot lie about it too much. So what I remember from college that these assemblies, like if you consider that you have a CPU of 3 gigahertz, so that CPU runs on a cycle of 3 billion cycle up and down, right? If I'm not mistaken, maybe correct me if I'm wrong. For every of these instructions, it only costs 1 CPU cycle. So we can run 3. Yeah, no. Partly, yeah, okay, I was not correct. So let's say half of it. So we can run these instructions very, very fast. We're talking about 3 billion. Let's go with half, like 1 billion maybe. Is that okay? 1 billion instructions per second on average, which is really nice. So let's talk about object. This is all gonna come along pretty neatly. Be confusing at the beginning, but stay tuned. So this is how we define an object in JavaScript. Yeah, no shocking. And this is how we define object in other languages. So this is C++, how you create an object, and this is Scala. But what's interesting about JavaScript is that you can expand on the existing object. So you create an object, you add compiler to it, you add history to it, and then later on you change the history, change the type of it, which is completely allowed. It's a dynamic language. You can do whatever you want. Shout out to Tretun people. And then you can also delete properties on an object. So the challenge here is that we need to have a compiler to understand this code and be able to cope with these changes to be able to run this code as fast as it can. This is not something that you can see typically in other typed languages. There are other use cases for objects as well, of course. You can define a dictionary that has just key value pairs. And the value of this dictionary doesn't need to be the same. Could be a string, could be a number, could be an array, like the last one. Found it yesterday. And you can access it quite easily as well. On line 9, you can say, oh, give me the value for hey. And what's interesting to me is that, OK, how does the compiler know, or how does the interpreter know where to find the value of hey in the memory? I think that's quite interesting. So if you dig into this, you will see, well, if you dig into it, but one of my questions when I saw this, I was like, OK, there is nothing special about having this type of objects where I can modify things, right? You can just create a hash table, right? In other languages, they have hash table. You can just add, modify, and make things make things available. And JavaScript uses hash table under the hood to store some of these things. But this is very slow. And I'll just let that sink in. Because to me, hash table, like we have learned it in books that like hash tables are like order of 1. In interview questions, they always ask you, okay, what's the order of hash table? It's 1. You don't consider it to be slow. It just it's constant. But if you dig into it, you will see that well, there is a price that you are paying for it. you have to calculate the hash based on the string that you're giving to the table, giving to the hash function, and then try to find the index of that that produced a hash in a bucket, and the bucket could increase in size or reduce in size, and then there is a collision of versions, collision of hashes, where you end up with a linked list. So it could be very expensive. So this is actually considered to be very slow, and this is what JavaScript does. At least V8 does under the hood. There are 3 types of object that you can have in JavaScript. So we have slow objects that we talked about that uses hash table. And there's fast objects and very fast objects. And these are the names. I have not created them. That's how they refer to these things. And when I read this, I was like, wow, how could you make a faster version of hash table? So this is how it looks like. So when you, in JavaScript, say const a equals new object, this is what happens. You allocate a chunk of memory for that object. And then it has various stuff that you can see on the page, on the wall or on the curtain, that I will get to part by part. So ignore the right side. They are all pointers. We don't care about it. We have this chunk here, the white part that says in object memory, in object properties. What happens here is that, remember the dictionary that I defined with the Swedish keyboards and the English one? So those are the values that will be stored in that white part in the memory chunk. What is interesting about that is when someone wants to access any of those properties, any of those key pair value in the dictionary, once they access one of them, the memory is already available in whatever you want to call it, L2 or L1 cache. So it would be easy for the program, for the interpreter, to access another property. It doesn't need to pay the cost of the round trip that takes stuff from the memory and bring it to the CPU so you can access it. So this is considered a very fast object. So if you define an object and don't add anything to it, it would become a very fast object. And then what happens if you have an object and then later on you add something? Remember the first example? We had an object, we added history, we added, what else did we add? We added some compiler and those kind of stuff. What happens is that we already have allocated a memory for that object, so we can't really change that. We are not going to pay the cost of copying all the memory and put it somewhere else just so you can add another property. So what would happen is that it's going to use, what the color is that? It's orange one. It's going to use the properties. Yeah, it's orange on my screen. It's going to use the properties pointer. So it's going to store that value in an array fashion, in an array fashion. And I will show you all of this. It's quite interesting. And then you will have a pointer to that value from the hidden class. So it tries to create a shape for the object. So you added something, you added history, you added compiler. It's going to add those stuff, including the descriptor, like if it is enumerable, if it is configurable, writable, the value, all of that will be defined in the hidden class, that there is a pointer to it in the object itself. So this is considered a slow object. And then we have a slowest object. Was that the term? Yeah, the slow object, which was the hash table, hence the dictionary that you see here. So if the compiler fails to be able to maintain this fixed array, it's just going to fall back to a hash table. It's going to say, I'm not going to do any more optimization to this. You're on your own. It's going to be a hash table. It's going to be still fast, but it's not going to be as fast as it can be. So let's look at one of the very simple examples that we can find in typical code. So let's say I have this function that I'm passing an object to, a player in this case, and I want to get the position of that player. It's very straightforward. But when it comes to the interpreter, this is actually quite hard to understand. A bit of sidetrack. Another behavior that JavaScript has is that you can create this kind of prototype chain. So you can create 2 variables here. I created Arya and created the girl. And then the girl has no name. It's going to have the prototype of Arya, which means that if you want to access the name of the girl, you're going to get the girl has no name. If you access the hair on the girl object, you're going to get dark, because whenever you want to access a property on an object, if it doesn't find it in in the immediate object, it's going to look it up all the way to in a prototype chain until it gets to the value. And you can see the demonstration of it in the picture below. So here, what happens here is that every time that we want to access a property on an object, we need to do various things. And there's a few more things that they have to do that I haven't got into, but it's a complicated process. So what happens is that if you call this method over and over and over, let's say thousands or millions or billions of times, what's going to happen is that the compiler is going to rewrite this function. It's going to make it optimized. So what's going to do, this is not a valid JavaScript, but just to show you the indent of what's happening under the hood, it's going to check the shape for the player. And if it has seen the shape of the player before, it already knows where the property is stored. It's just going to return that. It's not going to do a lookup anymore. It's not going to look up the prototype chain. It's just going to return the value. And if it is not, then it's going to fall back to the optimized version of it. So this is important. The shape of the object is important because some cases, let's say that you have designed a game where a player can die. And then, so you set the player B is dead, true. So what happens here is that you have actually changed the, oops, I think I should go here. You have changed the shape of player B. Player B and player A no longer have the same shape because player B has something extra, which means that the function that we used to have before, that was very nice. Now it has to check for two different shapes. It has to check, OK, if the player matches that shape, the first player shape, return that one. Otherwise, check if the player has the second shape, return that one. Otherwise, de-optimize again. One way that you can avoid this, for example, is to store properties. Well, this is a dumb way of doing it, but shouldn't swear. But this is something that you can do because when you store things on the indexed part of the object, you're not changing the shape of an object. So you would still retain the shape. So you can do this kind of trick. I wouldn't recommend. The better way for this would be if you had defined is dead for all of the players. So all of them will have the same shape, and then you just set the value true or false. So it's quite interesting to me because it looks like that V8 is trying to add as much hints as possible that you feel is unnecessary, but it actually makes things faster. And I have some demo for that. Everyone can see the code from the back? Yeah, awesome. So I have this example where I have defined a bunch of variables, a bunch of objects. All of them, as you can see, have the same shape. They all have name. And what I do here is that I have an iteration over 1 million or 100,000. It's hard to tell. Creating random number, and then I'm calling a method randomly with any of the objects that I have in my languages. And I have this function that just returns the name. So it's very similar to the example that I showed you, get player position. So this is something you can do already with Node. So I can say print bytecode, a.js. And yeah, this is going to be a lot. So what I'm going to do, I have installed something that is called D8, which is the compiler that is behind Node. Yes? I did. Oh, thank you. Yeah, that was perfect. Thanks. But yeah, thank you. So I'm going to use D8 to compile it because Node gives me some extra stuff that I don't want. Like it gives me the compiled code for FS, HTML, HTTP, and other things that I'm not interested in. I'm just interested in the JavaScript part. So I've installed that, and there's an instruction slides for it just to show you how it looks like when the interpreter compiled this. So you can see there's a function getName, and it's very simple. It just puts it in the stack and then load the named property. So this is the intermediate language that we talked about. But let's take a look at what this one is under the hood. How does that convert into bytecode? What? Well, it didn't happen so far. Yeah, exactly. It should never happen. It's very, very rare. So it's okay. We merged it, ship it. So what's interesting about this code is that for loading a property on an object, we have to pay the cost of 35,000 instructions, which seems a lot, but it runs very, very fast still. But V8 says that I can do better. So what they do, you can run this as well. I think it's called print opt code. That prints the optimized version of the program, and all of that code, including the while and the random and everything else, is shrunk down to only 1,300 lines of assembly code. Because now it understands the code. Now it understands that you're passing the same shape of object to this function over and over, so we can optimize it. So I'm going to take care of all the code that is not necessary to run. So let's see what happens if I add some more stuff. So I say dynamic, true. I'm going to say static, true. So my purpose here is to change the shape of these objects. So now I have created 4 different shapes of objects. 2 of them are the same. And I'm going to optimize this code again. I'm going to show you that if expression that I mentioned in this slide. And here's the one. So we are comparing the shape of the object that we have received. If it matches the shape 1, we already know where it is. We don't need to look it up. So we have those 4. And it just happens that optimizing this code would only work if you work with 4 or less type of shape of object. So if you have another shape of object, let's say that, I don't know, foo, true, then it's not going to optimize it at all. Just going to I'm just going to calculate every time. So this is one thing that you should be aware of. If you have a function that gets called many, many times, you can optimize it by making sure that you always send the same shape of an object. How much time do I have? 5 minutes, okay. I have another example to show. Let's see, no, that's not the one. Here. So I have this application. So you can do this also in Chrome. These are just noise, just so I can find the object in memory later. So it doesn't matter. The most important part of this code is this. So I'm creating 3 variables. They all have the same shape, but the value of those shapes are different, right? So, but they have the same shape. And I can prove that to you by running this code. Actually, let's refresh in case I had already one in the memory. So you can go to the memory and take a snapshot. And I'm going to search for the constructor that I had. And you're going to see that I have an object now in memory that has A, B, and C. And just to show you that the shape of these objects are the same, you can take a look at what the value is available in front of the map. They are the same, 18, 42, 81. They have the same shape. So if I send this object to a function, V8 can optimize the heck out of it. So let's see what happens if I tamper with that. So I say a.t equals, I don't know, t value. So I added a variable to my object. Let's take a look at what happens under the hood. So as you can see, it's hard to see both of them in the same page. Let's see. So we have a map here and map here. They both have different addresses. They have different shapes, and you can see that. Remember the properties on the memory of the object? That's where it is. So now my object has become slow object. Well, fast object from very fast object becomes a fast object. If I repeat this, if I try to, I don't know, if I try to delete one, the compiler or the interpreter is going to just give up. It's like, you're doing too many changes to this object. I just can't handle those many changes. So I'm just going to, it feels like that you're tampering with this object too many times. So I'm going to just create you a dictionary. So if I record, program, you can see that my properties is now a dictionary. So it's going to copy all those values that I already have in my fast property and put it in a slow property for a lookup. Yeah. So there are useful instructions how you can install the 8 and some of the cool stuff you can do with it, which is really nice. You can join the dark side. So just to recap, so we have this kind of object language. We are adding stuff, name, type, a JIT, and then we are deleting something on it. So this is what's going to happen in the memory as we are going through. We are starting with the empty memory. It's going to change the shape. So what you see on down there is the hidden class, the shape of the object. So we have added the name, so it's going to create the name. Now we added the type, so we're going to add another type. And then all of these values that you see have a pointer back to where the value is. The value may be like in different part of the memory. Like JavaScript could be stored in this part of the memory, dynamic could be stored here. Yes. And then we add more and more. Go for it. So this is another interesting, cool thing to know. So I have these 2 pieces of code. They could run at any time. It could be like one button runs the one and the other button runs the other one. What's interesting is that on line 3, both of these objects have the same shape. So it doesn't matter when or where you created these objects, as long as you have the same properties on those objects, they will have the same shape. Another interesting thing is that you typically find yourself in situations where you're just creating objects like this. And you would think that, OK, they have the same shape. Both have names, both have types. But that is not the case, because the order of those properties matter. I don't know if any of you guys have seen this ESLint rule that orders things in objects, and you felt like that is a very useless thing. That is actually used for this kind of case. So they have the I forgot about this. They have different shape. So if you're using this these objects to send it to a function, it's not going to be able to optimize it very well. We have the same situation in an array. I will try to fast forward. We have like 1 minute. So we have an example where I have prime numbers, and this is how it looks like on the memory. So I allocate 4 slots on the memory and no more, because that's what the user asked me for. I'm going to push another number to this array. What's going to happen is that it's going to just throw away everything that it had, because it didn't have any more slots to put. And it's going to allocate a bit more than what it was needed. So it's going to allocate more than 5 slots. It's going to keep them empty for now, because it thinks that you might add more stuff to it later. But you are paying the cost of garbage collection of the previous array that you just threw away. If I add another number, but in this case it's a double number, it's going to actually, again, throw away everything that it had before. It has to convert all of the numbers from an integer to a double, because the arithmetic and all of those optimization that it has for different arrays are different. So it's going to tag the array to be treated differently. It would be the same if you add some arbitrary stuff. So what's going to happen if I try to set a value on the 5th element? The 4th element is already null. What's going to happen is that it's going to become an holy array. And this is important to know, because the optimization that works on an array, if it is not holy, is very, very fast. But if it is holy, then there will be an if expression every time you want to access an element in an array. It has to check if there is a value, return null, otherwise return the number. So you're paying the cost for that if expression. And what happens if I try to put an item on the 10,000th position? It's not going to allocate 10,000 elements. So it's smart about that. And it's just going to put it as a property of an object, because arrays are also already an object. So it's going to just put it in a property key value store and just get it over with. And then it changes also the optimization that happens with the array. So the array in this type is going to be very, very slow when it comes to reading. So just to recap, I think JavaScript is a very interesting language. It is weird, but it's very, very interesting.
Right. Hi, everyone. Hello. Can you hear me? You can hear me. Great. OK, so this evening I'm going to present very quickly the ubiquitous nature of JavaScript. Okay, so this is the title. Quickly about me, I'm from Gothenburg. I'm actually English, but I've been living in Gothenburg for the last 20 years. Yeah, I'm from Gothenburg. I work at Callista Enterprise. We're a consultancy company in Gothenburg and Stockholm. Current assignment is at a company called Recorded Future, and also I'm the organizer of the React.js meetup in Gothenburg or Göteborg, where David's going to be talking on Thursday. Where is he? David. So it's really exciting to be here and give a presentation, also to see the group here in Malmo. You can see that this is taken from today, but we're up to 1,025 members in Gothenburg for the React.js meetup, which is kind of crazy. So React is just it's getting bigger and bigger. But I always feel that React and JavaScript are just kind of like this, really. So although it's a React.js meetup, it's very much a JavaScript meetup as well. So if you're ever in Gothenburg, please come in. Okay, so this is the agenda quickly. So first of all, I'd like to just talk about the inspiration for the talk, my dream stack, developer experience, super important, backend for the front end, serverless framework, polydictate, landscape and code. So this is the demo I'll show you that I built with serverless and also React Native, which I chose for this as well. How many of you have worked with serverless? Has anyone worked with the serverless framework? Okay, in AVS or in Azure? Yeah. Okay, cool. So hopefully this will make sense to some of you. And if I tell any lies, please tell me. Okay, so inspiration. The inspiration from this talk came when I went on my AVS developer training up in Stockholm a couple of months back. And one of the things that scared the hell out of me was that the labs that we did labs in Java, .NET, and also Python. And me being a serverless kind of, crazy person, I was just like, what the hell is this? So all of a sudden I was transported back to 2005 using Eclipse. And there was like this fantastic kind of deploy icon where you just deploy your stuff. And I was just like, man, what is going on? And then we spent most of the labs just clicking around the Amazon console. And I just kind of thought, this is supposed to be the future. And it just reeked of enterprise damage. I was like, what is going on here? Here we are with some of the most amazing technology known to man. And I'm using Eclipse from 2005, clicking around a GUI. So I just thought there's got to be something better than this. So I sought solace with Rick and Morty, my favorite cartoon, which I watch a lot with my son. So this was the other thing that gave me a lot of inspiration for this particular talk. I hope it's going to come up here. I don't know if any of you watch Rick and Morty. Sound. How do I turn the mic off? Okay, never mind. And then a meteor, and they could giant cat monsters, and then a giant tornado. A Mexican armada shows up with weapons made from two torpedoes. You better bet your bottom dollar that these two brothers know how to handle business. Alien invasion, tomato monster, Mexican army brothers who are just regular brothers running in a van from an asteroid and all sorts of things. Hold on, old women are coming. They're also in the movie. They're gonna come across two brothers. But let's get back to the brothers because they have a strong arm. You don't want to know about it here, but I'll tell you one thing: the moon comes crashing into Earth, and what do then? It's two brothers, and they're gonna. It's called Two Brothers. Yeah. So why was this an inspiration for this talk? You're probably wondering. How do I get back? Let's get back. Okay, where's Where did Keynote go? Okay, here I am lost in space now. Just a minute, where's Keynote gone? Keynote. Escape, here we go. Right. Yeah, so this to me as a front-end developer, this is how I see it. First of all, the asteroid hits you. The two front-end programmers doing your job, moving ahead, moving really quickly, using JavaScript, everything's great. You need to do a new feature, then you need to speak to the back-end team. Okay, so this is the first bit, the asteroid hits you. And then also all of a sudden you're arguing about whether you need a REST API or a GraphQL API. And of course you're programmers, you want to use GraphQL. So these are like the cats. So you get into this huge argument about REST versus GraphQL. And then you've got your pull requests and your code reviews, and this is the Mexican guys firing the tomatoes at your code. And then there's just general madness. You don't know what the hell's going on. And then the project process comes down on you like a ton of bricks. And this is the grannies coming down at you. And then all of a sudden there's just bankruptcy and you need to do something else. So anyway, my dream stack, using the serverless framework and also using React. And one of the things that I love about my dream stack is DX, okay? And I just say that again, is DX, and I just say that one more time, is, what does DX stand for? Yeah, okay, that's it. Yeah. Exactly. So, like, I mean, now as a front-end developer, we have the world at our feet. Basically, we have so many amazing patterns, and we have so many amazing libraries that we can use. We have React, we have RxJS, we can use Ramda for functional programming, we can use Jest for testing. We've got GraphQL, we've got TypeScript. I mean, the list just goes on and on and on. But throughout all of these libraries, there's some amazing patterns which are very similar to what back-end developers would use. RxJS, for example, you just use that in the back-end, definitely. TypeScript, you could use that very much in the back-end. Redux is almost like an event sourcing light. So if you're using Kafka or something, you could use, Redux for doing a similar kind of thing. Maybe. So anyway, front end's back end. So I want my developer experience. I want a minimal context switch. I want really good tooling. I want code as infrastructure. I don't want to have to click around on a deploy on a console. I just don't want to do that. I want to be able to write stuff, deploy it, deploy it. I want it to be, clean and neat. I want good patterns and conventions, and we have loads of those at the moment within the JavaScript community. And also, I'm personally an advocate of functional programming, so I want functional programming, and JavaScript gives me that. So, from silos to cross-functional teams. Basically, one of the great things with the serverless framework is that it enables a JavaScript programmer to be able to work in all the tiers. You can be starting in the front end, and then all of a sudden you need an API, you need to access a database, and you can just use your JavaScript skills within the serverless framework. So serverless gives you, first of all, it gives you JavaScript as the language that you can use to be able to create your functions. You can also program in languages like Kotlin, Java, Scala, Go, Rust. You have code as infrastructure. You have a plugin model, so you can run everything offline. So you can basically simulate a whole AVS stack locally, offline, which is very cool. For testability, uses Webpack, which most of you are probably going to be used to. You've got SNS, you've got SQS, you've got the whole AVS infrastructure at your fingertips. And also, you have the ability to be able to deploy to multiple clouds. So, if AVS is not your thing, you can deploy to Azure or even Google Cloud, I think. But AVS is definitely the best. Okay. So just to give you a quick idea of the landscape of what I'm gonna build or what I've built for you. Basically, there's a bunch of Lambda functions. There's an API gateway. There's an MP3 S3 bucket. We have a notes Dynamo table. Everything is kind of secured with Cognito. So we have security. We have we're using IAM roles and stuff. And then also in the client, you've got AVS Amplify, which we use to connect up to the back end or to the cloud. And I'm using React Native. So with React Native and using Expo in React Native, it gives you the ability to be able to deploy to iOS, Android, and actually also to the web. So, you know, for using JavaScript and for using this stack, you know, you've got a huge possibilities, you know, of being able to deploy to all these different platforms, plus to be able to run this code in the cloud, you know, on a global scale, you know, huge. So let's just have a quick look at a Lambda function. That is it. It's just you can write a Lambda function just in one line of code. Now, as a best practice, when you're using serverless, it's good to keep your Lambda function, if it's an AVS or even an Azure, as thin as possible, and then kind of like delegate out to some kind of service or something, which would in its turn call Dynamo or link up to some other kind of AVS service, for example. So, I mean, the get function is basically you're sending in an event which comes from the API gateway, and then my notes service will just do a get, and I pass in the ID. So I just want to get a particular note, a single note. That's it. Code as infrastructure. In serverless, you have a YAML file which basically translates over to CloudFormation. CloudFormation templates can get really huge and really difficult to understand. So with serverless, it gives you a way of kind of breaking up everything into smaller chunks in a kind of manageable, kind of understandable way. So if you look at that Lambda we just created there, you specify the handler, which is the JavaScript function. You can specify environment variables. So we're passing in the name of the database that we want to call, which is the Polynotes DB. You specify the path, notes / some kind of ID that you want to go in. Integration is Lambda, so you've got integration between API gateway to your Lambda function, cause, and then you can specify request parameters and stuff. So it's kind of neat and it's logical, you know, it kind of makes sense. Yeah. And also you can write tests for this, you know, which is really nice. And the testing you can use, if you're used to using Jest or Mocha, you can use exactly the same testing in the back end as well. So you get this kind of ubiquity between you know, just writing a Jest test in the front end and then being able to do it in the back end as well. And with a bit of magic, you can set this up so you can test locally and also remotely. So without further ado, let's go to the demo. Right. Let's go over here first. There we go. What's the time? Okay, I've got 10 minutes. Oh my God. Not much time. Okay, so first of all, what I'm going to do is just show you running the offline stack. So when I run the offline stack, what I'm doing is starting Dynamo. I'm starting an S3 service. I'm starting an API gateway kind of mock, which I guess is like Express somewhere down there, which will expose the Lambda functions that we create. Okay, so this is the whole stack. There are plugins for SNS and also for SQS, so you can simulate the whole kind of event-driven stack if you want, which is very cool. So just starting it, I do yarn start. Okay, it starts up here, and you can see, you know, you get some information about what's being exposed, what the API gateway's exposing to you. And you can see those URLs here as well, which is kind of nice. Also, you can see that we're starting a local DynamoDB, and you're starting up a local S3 as well. So if you can think back to that landscape, basically what I was doing was sending in a request, going to the Dynamo table, and then if we request an MP3, that MP3 lands up on our bucket. Okay? So just to show you testing locally. So yarn test local, it's a bit small there, isn't it? Let's just increase that in size. So I've just created a bunch of tests which basically fill up the database, if you like, or just tests that you can create a note, you can update a note, you can get a note, list notes, and also search for a note. Okay, and you can see they run really quickly. So, you know, if you're into test-driven development, it means that you can have a test runner running in the background and you can just be writing code and sort of doing code. Okay. The other thing is that whilst on the train today, I created a GraphQL Lambda for the REST endpoints as well, because I was like, okay, I've done everything in REST, but it'd be really nice to have a GraphQL endpoint, of course. So if we just look at this, this is running off of localhost again as well. And then within here, we can basically just write our normal GraphQL stuff. So if I want to get this particular note here, I can just change this. And then go ID and then go 12 just to get my particular note. Okay, so we can use GraphQL here, which is like really sweet. It's very nice. It's running locally, but also I've deployed this so we can run it from the cloud as well. So you can see that this is a horrible Amazon URL, and then I can hopefully run this. Let's just create a note. Let's just do this. So I've just created that note, and it's given me an ID there. Okay, so I won't go into this too much, but basically, you know, you can create stuff pretty straightforwardly. If we have a look at the that Lambda, or actually, let's have a look at this one. I'm using Apollo gives you a very nice implementation for AVS Lambda. So you can basically just hook this straight into a Lambda function and you get an Apollo backend. So you define your schema, which I've got here. So it's a note, you've got a message, you've got your queries, you're specifying your mutations. And then also you've got your resolvers down here. So for example, if I wanted to change anything here, it would just hot reload. So when I get a note, I can say this has just been changed. Okay, I save that, and you can see that in the server logs, it's listening for any changes. So everything's hot reloading in the background. So if I come back over to my GraphQL service and do a get here, okay, just fire off that get again. Over here you can see, you know, the update here. So everything's kind of happening automatically in the background. You don't have to kind of, you know, stop and start the server. You just get everything hot reloaded, which is really, really nice. Okay, let's go over to the client quickly. Oh my God, there's not much time at all. But let me show you the actual final thing. Okay, so this is the client. So it's pretty simple. Basically, it's a list of messages which you can send off to Polly. Polly is a service on AVS which basically takes a message and then it will apply its kind of Alexa type voice to that note. So let's see if we can have a listen to it on iOS. So here we can choose a name of Polly.
Nobody exists on purpose. Nobody belongs anywhere. We're all going to die. Come watch TV.
Okay, and then we can change the voice. I don't know, let's choose Joey.
If you get pulled over for speeding, tell the policeman your spouse has diarrhea.
Okay. Sorry, I'll just. So this is running on both the Android simulator and also the iOS simulator. So here I am with a mega backend in the serverless framework. Then I'm creating React Native applications for Android, iOS, and then also you can create web applications from this as well, which I haven't had time to do, unfortunately. But you know, obviously you want to be able to run it on your telephone. So just to quickly show you that it does actually work on my telephone, this is using.
Listen, Morty, I hate to break it to you, but what people call love is just a chemical reaction that compels animals to breed. It hits hard, Morty, then it slowly fades, leaving you stranded in a failing marriage. I did it. Your parents are gonna do it. Break the cycle, Morty. Rise above. Focus on science.
Okay. So there you go. All right, I'll leave it there. All right, thanks. Questions? So the source of the text is Morty, Rick and Morty. That was Rick. Rick's got like a whole bunch of quotes. It's one of my favorite things. I sit down with my son and we watch Rick and Morty, and it's just really stupid, you know. Yep. Pain points. I think in the YAML file, it's really important to try and split up the serverless.yaml file as much as possible. So I haven't done it for this demo purpose, but you can see that already it kind of gets big, and the YAML format is a bit of a nightmare because it's like too spaced formatted. So it can get very, very tricky and very messy after a while. But the idea really is that you should, like with resources, for example, you know, you should split all this stuff up so you can import all of the resources into this file individually. You can log and you can trace stuff directly directly from the cloud. So deploying stuff to a cloud is always a pain point, but you have a lot of tools here to be able to pinpoint where things have gone wrong. Yeah. Well, Amazon have copied the serverless framework with SAM. And the YAML format that you see here is exactly what you would use in SAM as well. There's a few differences. Serverless application model, I think it's called. But the thing with the serverless framework is that it gives you the ability to be cloud agnostic. So, you know, if you follow best practices with your Lambda and keep code out of your Lambda function, you know, all the different cloud platforms, they basically have this similar kind of Lambda signature. You know, it's an event that comes in and then you just do something, you know. Yeah.
Lambda functions has like certain limitation, like a runtime of 50 minutes, like how many concurrent instances you can have at the same time.
Yep.
When you're working with it, what types of like changes do you feel you do to how you write your code? Very big.
Well, you try and split things up as much as possible, and you try and create smaller increments. So, I mean, the go back to the landscape. If you look at this, I mean, when I was working at Telenor Connection, we basically built an IoT platform using exactly this technology. We didn't have like individual lambdas for each REST method. You know, we would just have like one. It wouldn't be like function as a service, but it'd be like mini services, if you like. So we'd have one lambda that kind of took care of all of this stuff, but you send in like an action, for example, into that lambda saying, oh, if you're going to get or if you're going to list or something. But I mean, the thing is that if you adopt a function as a service mindset, it means that you start having to think very differently about your architecture. You know, you need to really split things up. And another thing you have to be is cost effective. You know, you have to architect for cost. And that's something that most architects just don't do. You know, they don't think about it. They just create some big monolithic thing that they chuck in an EC2 instance and run it. You know, and they pay per month, you know, on a flat fee. But with Lambda, with function as a service, it gives you the ability to be able to get a cost on the exact invocation time, you know, the compute time, how long you're in here, and you can see your costs directly, especially when you get into using DynamoDB. You know, at first it seems really easy and really simple, but this gets really, really super expensive after a while. You know, so you have to rethink how you architect things, I think. Yeah. Yeah. Okay. Yeah. Yeah. Sure.
Do you want to see when other people add notes, like at real time?
Yeah.
Normally, I use something like an event source or WebSocket, but
yeah.
you can't have one running connection. What would you do with this second?
Oh no, you can have WebSockets. No, but you have everything's event based. So you have, like, for instance, in Dynamo, you have something called Dynamo Streams. So basically, whenever you get an update happening in Dynamo, the Dynamo stream could go out to a Lambda, notify the Lambda that a new note has been added, for example, and then send that out on a WebSocket, or send it out on an IoT queue, an MQTT queue, or whatever. So everything's event based. So I mean, this example is very much request reply, you know. But I didn't really have time. I wanted to do WebSockets, but I didn't really have the time to get it into the picture. Yeah.
So you know, I think we have a request that you know, process it.
Mm-hmm.
To some degree. How do you deal with that?
Well, as far as spinning up an environment, I mean, basically, when we want to deploy this, you just do serverless deploy, and it will deploy all of those functions. The deployment process is really, really painless. Okay. Yeah.
Doesn't that have some issues?
What are you talking about, the network request between the API gateway and the Lambda, or are you talking about the network request externally from Lambda and Lambda? I'm not sure, actually, to be honest. It's a problem we've never had. You know, we can do you can do Lambda and Lambda to Lambda communication, but it's something that we've never really experienced as being a problem. So I can't say that I've had to think about it, to be honest. Yeah. Sorry. Yeah. Yep. No more questions? Okay. All right. Thank you very much. Yeah. Neo4j. Yeah.
Come on, don't be don't curse
Yeah, it is. Yeah. There's an Aurora service which basically spins up a serverless RDS database. So that can be MySQL, it can be Postgres, or it can be whatever. And when I say serverless, it means that the database isn't up and running all the time. It will run on invocation. So I don't know how AVS have done it, but they've basically enabled you to be able to treat it as a serverless service, which is pretty cool. Yep. Okay, thanks very much. Thanks.